Hello. Hello.
Hello.
Yeah. Good morning, everyone, and ladies and
Gaurav, have you done mute all or not?
yes, ma'am. I've muted everyone.
Okay, thank you. Is it going to be live on YouTube? What's the, please ask before starting the session.
Just a second, ma'am. Yes, ma'am. It's going to be live on YouTube.
Okay, so you'll have to put on, somebody who is host has to put on here on more somewhere. Are you doing it or what?
Yes, ma'am. It's live.
Okay, it's live.
Okay. Yes, ma'am. I'm doing it. Okay, let's start. Um,
Okay, very good morning, all of you. Uh, after this inaugural session, uh, let us try to understand those who have no experience, past experience, on what is AI. Uh, so, let me share my slides. I hope you can see my slides. After these wonderful lectures, inaugural lectures by our chief guest and the guest of honor, Chief Guest Dr. Gopi Chandra and guest of honor Bala Subramanian ji, and then lectures by Professor Bhartendu Singh, Atul Gupta sir, and ma'am. Many of you know that there are several important opportunities and challenges in the field of artificial intelligence. So, let us look at two very important developments that took place last year. That Nobel Prize in Physics was given to people from AI. Geoffrey Hinton, we can call him the founders and father of modern AI, and John J. Hoffield, who designed Hoffield Network and many other things. Their work was recognized for their foundational discoveries and inventions that enable machine learning with artificial neural networks. Uh, so it was something which was came as a surprise to people in physics community and also in science community. And then Nobel Prize in Chemistry was also announced, where two young people, John Jumper and Demis Hassabis, were awarded with Nobel Prize in Chemistry, and this was shared with uh, David Baker from University of Washington. The idea was that these models, the current generative models that have revolutionized the world, have also given directions for solving many old problems. Like here, I can see, you can see that they developed an AI model to solve a 50-year-old problem, predicting proteins complex structure that otherwise was difficult to imagine. So if I look at the history of modern AI, the current neural network model that is being used has its origin in this paper by these two great scientists, McCulloch and Walter Pitts. They defined a logical, they actually gave idea of the current neural network model by giving a logical calculus of the ideas immanent in nervous activity, human nervous activity. So, if going back to the past in 1955, Alan Neville and Simon, they developed the first artificial intelligence program to mimic the problem-solving skills of humans. What is the idea? Friends, the idea is that we learn to know how humans' brain works. Human brain is intelligence of aspect of human brain is based on problem solving skills by perception, by listening, by understanding. How we are able to do that? So one of the very first problem that was thought of was how humans solve problems. It is not only mathematical problems, but also real life problems. So to mimic the problem solving skills of this, they were able to design first artificial intelligence program. So this logic theorist led to the development of symbolic AI, which is now known as good old-fashioned AI, GoFi. And that laid the foundation of important research in AI. And if I look at the evolution, history of evolution of AI, the first Dartmouth conference was held in 1956, where the term AI emerged. And then, starting from logical problem solving to general problem solving, then Frank Rosenblatt came out with a perceptron model and they experimented. They designed a machine that's showing first successfully implemented model of perceptron. So then came the dedicated programming language called Lisp. And people started thinking about how knowledge is represented in human brains. And so expert systems, knowledge representation, knowledge engineering, this was developed around 1960s to 80s. And if you remember that we discussed about transformation model in the inaugural session, transformation model is it has its origin from a recurrent neural network, where recurrent neural networks were primarily designed, neural networks primarily designed for understanding the sequential pattern of data, right? Like language is a sequential kind of data, speech is a sequential data, weather forecasting requires sequential understanding of data. So all such problems can be very well understood by applying recurrent neural network. And then came the context of like, how do we understand, how humans understand by watching something? So how human perception is like achieved by watching something. So it's a vision based understanding. So then people understood that for spatial understanding of things, different types of neural networks are required. So convolutional neural networks were designed. And then came IBM that made a sensation 1997 when Deep Blue chess machine for the first time in the history of AI was able to defeat one of the most intelligent humans, Gary Kasparov, who was a world champion in chess. So this was a wonderful discovery, I should say, achievement of AI, where we could achieve intelligence, better intelligence, or at least at par with human intelligence. Then Honda designed SEMO, which are still very actively used, humanoid robots. Then Hinton Group introduced the concept of deep belief network. what happens in neural network, we have certain neurons and there are several layers of neurons. And when there are large number of layers of neuron, training the model to learn something becomes exceedingly difficult. And Hinton Group came out with a wonderful solution known as deep belief network, where they designed an algorithm so that very such deep neural networks could be trained. And then LXNet was introduced in 2012. And then Kemming he came out with a wonderful ResNet model with 152 layers and millions of parameters of neural networks. This was for the first time that vision-based intelligence was achieved by a neural network which was at par with humans. And in fact, they showed that an average human makes an error of 5% in understanding the scene, whereas their algorithm was able to obtain 3.57% error. So, in the same year, 2015, AlphaGo came out. AlphaGo defeated Go champion Lee Sedol, where Go is a much more complex game than chess. So Go is a Chinese origin game, and this AlphaGo defeated the Chinese Go champion Lee Sedol, and that was also a sensation. So what was the basic difference between this model that was able to defeat chess master Garry Kasparov and AlphaGo master Lee Sedol? This model was purely on logical programming, logical based. And this was based on learning, right? So there was a difference between these two. And then all of us know that ChatGPT was launched, that made a sensation. And then DALI for image generation, if you give text prompts, DALI is able to generate text. There is a plethora of language, image, video generation models that have come in recent years. So basically now generative AI is in action. Well, Professor Gupta, in his speech in the inaugural, was talking about understanding the requirement of a software and how do we automate this idea. I'm very happy to tell all the participants that just 5 days ago, Alpha Evolve, a Gemini-powered coding agent, has been introduced for designing advanced algorithms. Can you believe that advanced algorithms, which are primarily designed by humans, they are actually designed by humans for doing difficult, very complex tasks. Now we have an AI agent. Given the requirement, you can design the algorithm. It can help you in designing the algorithm, refining your algorithm. That is really a sensational news. So when we talk about AI is doing this, AI is doing that, what is AI? So AI, if I look at the definition of AI from different people, it emerges that AI is a technology that that works with human-like problem-solving capabilities, human-like understanding. So AI in action appears to simulate human intelligence, right? It can recognize images, it can write poems, it can make database based predictions. So think of anything. Right now, the current definition says that, as is given in AWS Amazon, what is AI? It is mimicking human intelligence. Similarly, in IBM blog, you'll find that AI is a technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy, right? So different people understand AI differently, depending on their application domains, their domain of expertise. But a common thing that emerges is that AI is there to simulate human intelligence. Human intelligence can be in the form of problem solving. Human intelligence can be in the form of understanding the scene, taking actions, making predictions, or human intelligence can also be in terms of sensing something, right? And human intelligence can be in the form of emotional intelligence. Right now, AI is mostly dealing with these biologically observed things, but there are many things to achieve. Like, how do we look at the emotions, feelings, and how people understand each other's emotion by just looking at the face of people, right? So, all these things are yet to come, they are yet to come. But in general, we can say that AI deals with mimicking human intelligence. So, what is an AI system? If I look at this picture here given on the right of my page, this page, AI system is having an agent. So let us assume that there's an artificial agent and which is working in an environment. Environment can be a manufacturing shop floor. Environment can be a customer support system. Environment can be a robot moving around. We just saw that in Indian army is having intelligent systems. So AI can be in defense area. So environment is basically the environment in which AI agent has to work. So an agent is an object. It can be a hardware like a robot, or it can be a software like ChatGPT that can gather information about its environment, right? And then take decisions or take actions based on the information that is given to it. Well, agents can be of several types. I will come to that later. But you can see that the agent is having some abilities. It may have some goals or preferences, right? The goals can be, for example, goal can be, if it is an AI agent for Amazon or for Flipkart, the goal can be how to reach, be more visible to people who are potential customers. That can be goal. And then it has some prior knowledge. This agent will have some prior knowledge that uh, so that prior knowledge, how do we gain prior knowledge? By experiencing, right? Humans gain prior knowledge by experiencing the world. By this I mean prior knowledge, how a child learns to speak by experiencing others are speaking, by experiencing how others are walking, right? So it has some prior knowledge and abilities. By abilities, I mean walking and talking. These are abilities, but it has some prior knowledge based on which agent in a given environment can take action, right? So the environment, it is sensing, observing, it also may be having some past experience. So based on the knowledge that under this, when this is the scenario, what decision is to be taken, that is the knowledge. So accordingly, based on the past experience and observation and the knowledge gained, it takes some actions, right? So agents can be, now reflex agents, like they do not remember the past, whatever is the current situation, they behave like that. They can be goal-based agents. So goal can be, if some you are from computer science background, you may be knowing that there are search algorithms. Like these search algorithms are applied in Google Maps finding out the shortest path from or exact path going from X place to Y place. So search based, they can be search algorithm. Then there can be role based. We know that there are several role based agents are existing now. They have the role to recommend something, they have the role to answer your questions. So, and then utility based, and then we have learning agents. So currently these learning agents combined with these goal based and role based, utility based, these are making wonders in our real lives. So if I look at what is artificial intelligence, how it has evolved, so simple way to think about AI, as this blog says by Cole Stryker and Ida, that uh, so is a series of nested. When I say nested, that means AI, machine learning is a branch or part of AI. Nested or derivative concepts that have emerged over more than 70 years now. 1950s, the first time AI, 56, first time AI was coined, and the term AI was coined. The idea was human intelligence to exhibit by machine, machine exhibit human intelligence. Then came the AI, the idea of machine learning, that is AI systems that learn from historical data that is already given. And then deep learning idea came, which is a part of a machine learning that mimics human brain function. What does that mean? By this, I mean that how humans represent data, how humans represent the information, right? So, for example, if you are meeting somebody today, 10 years later, you can recognize the fellow because you have some representation of his face, his virtues in your mind. So this representation learning was what the deep learning is focused on, representation learning. And then came the idea of generative AI. Although generative AI is existing since long, but the current generative AI is based on deep learning models and deep learning algorithms, right? So we begin with the AI, and then machine learning, deep learning, and then generative AI. So when I am talking about AI and then I'm talking about learning also, I would like to tell my participants here that how AI, intelligence and learning are related. So cognitive psychologist says that learning denotes changes in the system that are adaptive in the sense that they enable the system to do tasks drawn from the same population more efficiently and more effectively the next time. What do we mean by this? That if you you request AI to give a summary of a document, it is providing you the summary of the documents from the same domain, but by learning how to design the summary, how to extract the summary, or how to find out the abstract, it will be doing the things much better the next time. That is what ChatGPT is also doing based on your inputs, based on learning better. It is providing you summary. So that is what. And then another educational psychologist studied the correlation between intelligence and learning. So he concluded that there's no clear distinction between the cognitive processes that contribute to individual differences in these two definitionally different realms, right? Definition of intelligence is slightly different than learning. Learning you do, but there is no distinction between them. So there's high correlation between intelligence, human intelligence, and learning. Why I am telling you this? Because why from AI systems, early AI systems, which were more on logical reasoning, by heuristic search, we moved on to learning. So this session, we are going to cover the concept of machine learning and deep learning. Okay. Please feel free in putting your questions on the chat box if you have any questions, anything that you want to know. So what is machine learning? Machine learning is like human learning. There are various ways in which we learn. So machine learning is a field of computer science that gives computers the ability to automatically learn, which is important, without being explicitly programmed. What does that mean? Without us being explicitly programmed means we will not be designing that uh, every single thing that if this is the scenario, this is the observation, then do this. If this is the observation, that then do this. It's not a programmable programming machine, but we expect the machine to learn by observing. Like humans learn many things by observing. Many things are taught to them, and many things are learned by observation only, like walking, talking, understanding the scene. Many things are learned automatically, right? So, learning from experience and data to make prediction. So, I seek your attention here. We have training data. So, in order to train the machine learning algorithm, you must show it some data. And so, we have some training data. Okay. This training data is passed through the algorithm. Algorithm is given input of these training data, and then the task that machine learning algorithm is expected to do. That can be prediction, that can be some decision making, that can be some recommendation, right? So prediction, say forecast of stock market, it can be forecast of weather, it can be forecast of many things, anything like forecast of how the user interest will go in a specific product. That can be a prediction. A decision, like it can be a decision that given an image data, we can see that this image contains a malignant object. If this image is an MRI image, it is containing a malignant object, or the MRI is normal. That can be a decision. It can also give you some recommendation by looking at the data. So depending on the task, whether it is that machine learning algorithm's task is to give you, like, predict something or make decision or to recommend something, that what is the product that the user will buy. If the user has already bought a pair of glasses, then what is the likelihood that the user will also buy something else similar to that. So what I intend to tell you here is that given a set of data, say weather record for last 3 years or weather record of say just 1 year, what is the likelihood that weather record of is available, that tomorrow it will rain, tomorrow it will be humid, tomorrow the temperature will be high? That is what machine learning algorithm is expected to learn. Okay. So the data is given, right? What it does is that suppose you have got some, say I'm making a small samples, only 100 samples, where 100 samples are, say, temperature, wind speed, the humidity level. Suppose these three values are given, and we are expected to predict the temperature tomorrow, right? Now, so this data is given, and we have some test data. So suppose for last 1 month, I will not show this data to the machine learning algorithm. I will show the data of last year, but only excluding last 1 month, and will expect it to produce some results. So this data, all these 100 samples are one by one fed to the machine learning algorithm. Machine learning algorithm understands the pattern, understands how it is changing. and then makes prediction. So what I'll do, I will find out whether it is actually making the right prediction for the last month or not, because last month data, I did not show it, right? If it is making prediction of last 1 month, each day of last 1 month, with say 98% accuracy, then it is deployable. The model machine learning algorithm is deployable for real world scenario. If it is not doing it, then what I will do, I will be again giving this 100 samples once again, telling that yes, it has made some errors. And then it will again try to understand that what are the patterns that it missed, and then will better understand the data. Just like you ask a student, we ask a student to do practice problems for understanding the pattern of questions and how to solve them, right? So suppose it achieves 98% in 2, 3, 5, 10, 15, 200 iterations. These are known as epochs. Every time you give experience of data, it is called one epoch, right? One epoch. So we give suppose 200 epochs. After 200 epochs, it is able to understand data and it is able to predict with 98% accuracy, right? So there is a question. I will be answering this question. The question is, I have a question. We use pre-existing models for machine learning. And as you said, they automatically learn without being explicitly programmed with the training data. But in order to do that, someone must have uh, explicitly coded the ML model, right? So we have explicitly programmed, right? So Swapnil, in fact, uh, how to uh, the algorithm is how to learn the data pattern. Algorithm is not about explicitly writing that if the weather today is windy, if there is high temperature, if it is humid, then predict that tomorrow it will be raining. Else predict that tomorrow it will not be raining, right? We do not program it like this. We we make a program, as you will learn how to program, how to create the structure of a neural network. And then you will be giving data to the neural network one after the other. Rest of the things it does on its own. By looking at the model, the task given for a given task, by looking at the data, what I need to do, so that it learns automatically. Nobody tells it that this is how you have to learn it. The only thing is that the error, we keep on telling the model that this is the error you are making. Now, accordingly, it will be improving its understanding of the data. So nothing like explicitly designed programmed. So someone must have explicitly coded the ML model. And that is what is explicitly coding of ML model, that you will have in your lab session. You will see that what exactly explicitly we coded. We code only that given this is the neural network structure and this is the error function that it has to minimize. That's all. Right? I hope I have answered your question, Swapnil. Uh, okay. Now, Juhi Faridi says, evolve AI by Gemini can create new algorithms, alpha evolve, yes. New algorithms like already existing algos or ML and DL or spiking neural network. Neural network is not an algorithm, Juhi. It is a structure. It is an architecture. It is a model that learns, right? By algorithm, like uh, by algorithm, I mean that we, for example, what is the algorithm that you have studied to find out the shortest path from X to Y place. That is an algorithm. What is the algorithm that finding out the minimum from a sequence of number? That is an algorithm. What is the algorithm that helps machine learning that helps a neural network to train itself? That is an algorithm, right? By algorithm, we mean the step-by-step process that we will expect our model to follow so that it learns. Just like the teacher tells you the step-by-step process to learn a specific course or a specific subject, the step-by-step process, like it first tells you that learn the preliminaries, like you will be learning preliminaries of linear algebra, probability and statistics in this. Then the next step is how to design a neural network. Then the next step is how to train that for a specific task. So this is step by step learning, right? But then once you know how to do it, you can apply it in any area. Uh, so Shivang Raman is saying nowadays it is seen that coders are making use of AI tools like ChatGPT to write the code. My question is that ethical step? Shivang, yes and no. Yes, because this is giving you a backbone for writing your program easily. But whenever you are writing your program, making use of any tool or taking anybody's help, acknowledging that is very important. In GitHub repository, also a lot of code is available. So how do we ensure that our students, when they are using GitHub repository, they should properly acknowledge that. So once you acknowledge, it is not unethical. Now the question is, do you learn actually? When you are getting the code written on your behalf, it is just like doing computation of, if I ask you do 546 multiplied by 320, will you not use a calculator? You use a calculator, and you will definitely acknowledge that you are using a calculator. So similarly here also, then you will, but you will not learn to do it yourself, right? So those who want to learn by themselves, for them it is better that they also learn to code themselves. So Tushar, we will be dealing with these algorithms in later session. And Shikha Shukla is saying, do we need GPU for these models, or we can use our system? How to use GPU? Please tell in detail. So Shikha, this we will definitely be doing in future. If the models are heavy, then you need GPU. Dr. Gopi Chand also told you that models can be edge AI. Now the fashion, like lot of trend is in this direction, is to develop edge AI, where you don't need a GPU to run an algorithm. Sometimes we need GPUs to train an algorithm, but running it may not require GPU. So once it is trained on, so coming back to this case, once your model is trained, right? Once your model is trained, you deploy it in a real world scenario, right? Whether it is a prediction of any disease, or it is a prediction of tomorrow's weather, or it is a decision of like you can see that based on the MRI image, any decision that is made. So all this is on unseen real world data. The model performs, trained model performs, and if it is performing as good as it performed here during the lab, like during when it was getting trained, then we can say that the model is doing well, right? So just like a doctor learns to do experiments and under the training of his superiors or his professors, a doctor learns to do surgery, perform surgery, learns to understand, diagnose a disease. And if the doctor goes to the real world scenario, opens his clinic, and then if his efficiency level is as good as it was when it was doing under the guidance of somebody, then we can say that he's a good doctor, right? Uh, so, Rajesh Kumar, we can answer these questions later. Uh, we will be definitely discussing about these things. Yeah, if I have 200 samples, I will tell you what to do. So, what is training? So, this is universal set. Let us consider that we are talking about a classification problem, right? I will tell you what is classification problem. So, classification problem is like, if suppose there is a universal set, we have a population in the city of Jabalpur that can be considered as universal set, right? From this city of Jabalpur, we want to find out the health index of people in the city of Jabalpur and find out whether they are above an average health index that is expected, they have good health, or their health is poor, right? So we have some data based on their height, weight, age, and then nutritional things, some symptoms, some blood test report. This data we have, suppose, right? And then this data, suppose there are 200 samples, all right? So this is universal set. From here, we take, we go, we go to different houses, we collect samples, and suppose 200 samples are there. These are 200 data samples, right? So some are, say, having not below average health, and some are having better health, right? So good health and bad health. Let us consider health index below a threshold, health index above a threshold. So now this data is given to machine learning algorithm. It observes data. It learns from experience on the data that, okay, this is the blood test report. This is the height, weight combination. And these are the things, nutrition value and all those things in the food. Then what can be the patient's health index? That is what it is learning to understand. So then it learns, it is doing well, very, very well here. It is dividing this into two groups. One is good health, one is bad health, right? So it learns to understand patterns for making prediction. These 200 samples are taken. Out of those 200 samples, if it is a supervised learning, I will tell you that how to deal with these 200 samples. And if it is an unsupervised learning, how do we deal with that? So training is the process of making system able to learn. That is what is known as training. Now comes testing. So now suppose we had 200 samples, and if it was a specific kind of learning algorithm that we call supervised learning, like your teacher is teaching you, or you are learning on your own, right? That can be unsupervised learning. So what we do is that out of these 200 samples, some samples, say 40 samples, we keep aside. And we give experience of only 160 data samples to this algorithm, right? Randomly selecting 40 samples out of this 200 samples, keeping them aside. And every time, I told you epoch, every time this 160 sample is passed through the data, like to the algorithm, it is making some prediction about health index, right? And so after, suppose one epoch is done, after 160 samples are shown, it is predicting good health and bad health with, say, 14% accuracy. Then I will be again, so on this training set of 160 data points, it is showing 1400%, 14% accuracy. I will now use after this epoch, this data also to check whether this 14% accuracy that it is showing is also here on these unseen data. This is known as validation data. Validation data. So whatever results it is showing on training, is it also showing on validation? So suppose validation shows some 12% accuracy, not seen data, right? Just like in final exams, even if we have done very well, in final exams, sometimes it so happens that we don't get to solve some problems. Some new type of problems come. So this is first epoch, then second epoch. It now gets a, say, 28% accuracy. The third epoch. So after every epoch, we also take care of this 40 data samples and check whether training and validation accuracy are at par with each other. Like it should not be very low than training. If it is happening, there is some problem with your training algorithm, right? So you will be requiring to do some modification in training process so that it is learning. And like after first epoch, say 14%, 12% in validation set. So this is training, this is validation. After second epoch, suppose 28%, and then 27%, say. After third epoch, say 50% here, and then here 52%, suppose, and keeps on going. And ultimately, you get, say, 98% here, and also you get, say, 97 to 98% here. If that is happening, then your training is doing, you're doing well. Your model is doing well on training. Machine learning algorithm is doing well on training. Right now, I'm taking actual testing. Right. Actual testing is what? Actual testing is when you deploy the model to the real world scenario, and new data is coming, right? Now you have deployed the model in the health center, primary health center in the city of Jabalpur, and now new samples come. New samples are coming, not those 200 samples. New samples are coming from humans, and then you are checking whether with 98% accuracy, it is giving you the same like accuracy level as it was doing when you were developing this model. All right. So, my dear friends, there are so many questions. I will answer those questions one by one. So, basic system configuration needed. We will tell you when we do lab sessions. I told you about 200 samples. Will increase number epochs also increase the accuracy of model? See, Renju Devi, I give you examples of two children. They are in my class. One of them is actually very intelligent in problem solving. The other one is good in sports, but is not so good in problem solving, right? So I am giving them training on solving, say, some mathematics problem, say quadratic equation, solving quadratic equation. This fellow who is good in understanding the patterns in mathematics will learn just after I give 3 examples, right? And it will show some 100% accuracy in problem solving. The second fellow will also be given the same 3, 4, 5, 10 examples, but it will not go beyond 56% accuracy. So, increasing of number of epochs may not always give you more accuracy of the model. Models may saturate after the desired level of, after it has understood, specific patterns, it may not be able to perform better. And sometimes by just 10 epochs, within 10 epochs, the model learns very well. So how many times the process will go? Shubham was asking. It will be until your like suppose your doctor tells you that okay, health index calculation, I expect at least 98% accuracy. So if the 98% accuracy is achieved in say 10 epochs, you stop there. 50 epochs, you stop there. 200 epochs, you stop there. If it is not achieved, then you have to rethink about your machine learning algorithm. Madam, wouldn't be training model being 98% mean the model is getting overfitted? Shubham, you have already some experience on what is overfitting. We will be talking about that a little later. So I'll come to your question. Tilok Doli saying we use the same data in every iteration, then why the accuracy changes in every iteration? Very good question, Tilok. So sometimes some people are slow learner, right? So the teacher teaches mathematics problems in classes. Teacher teaches language in classes. Some students learn quickly, some students take time. So the same data, the same types of problems, but some students learn quickly. So why accuracy changes in every iteration? So you know that you performed miserably in mid-semester, and then suddenly in end semester you have learned, which you did not think earlier the way, and so you were able to perform well in end semester. This is what happens in many cases. So Arpana Chaturvedi, why should be the best software? What should be the best software? No, there's no best software. Why are you talking about best software? You will be writing yourself software, right? All right, coming back to my this thing. So unseen data, it is performing equally well, then that is known as testing. So testing is the evaluation on the prediction of the model on unseen data. That is important. That is testing. All right. So machine learning algorithms is able to learn, extract patterns. Is we say machine learning algorithm is an algorithm that is able to learn and extract patterns. For learning is what? Learning is said to learn from experience. From experience, E can be experience on data with respect to some class of tasks. The class of tasks can be, for example, categorize these into two categories like good health and bad health. Class of tasks can be predict the weather tomorrow. The task can be, so there can be a class of task for machine learning algorithm. It can be a single task, it can be multiple tasks. Multiple tasks like find out if the MRI image is having some malignancy or some abnormality. If it is having an abnormality, find out where exactly it is located. So these are two tasks. And performance measure P. So measure will be based on the type of task that is given. So for example, if the task is finding out whether it is MRI image is malignant or not, is having malignancy or not, that is one task in which accuracy will be important. Where exactly is the malignant tumor or something which is there? Where exactly is this? So it will depend on the actual estimation and actual area where it was, the difference between them. So that can be performance measure. So what it says, what is learning? A computer program is set to learn from experience E on a specific task or a class of task T with respect to the performance measure P if the performance as measured by P improves with experience E. So just now some people were asking how by giving same data, how the experience, like how it learns better. So I told you example that there can be some machine learning algorithms that might not have understood initially the data patterns. By repeated experience of data, it learns better. Like I always give this example of children learning colors, but their moms and their dads tell them that this is green color, this is blue color, this is white color. Some children learn quickly that yes, this is green color. Even if the tint and shade of the green color is different, they are able to identify green color very well. And some children take time. But that doesn't mean that the second children is not intelligent, because he has also taken time, but has ultimately reached the goal. So the question is, what kind of experience? So learning experience, so task, like experience, I will tell you what kind of experience. It can be experience on data with a supervision, like your teacher teaches, experience on data without any supervision, and experience on data with respect to your own, like dealing with the environment, right? So we will be talking about that a little later. So what are the tasks? Tasks can be classification tasks. Like given a set of samples, classify them into different categories. It can be a regression task. Find out the temperature tomorrow. It can be a transcription task, like we saw many transcriptions are done. It can be translation, it can be generation tasks, many tasks are there. So performance measure depends on the type of problems, right? And measured on a data set called test data set that is different from the data set used to train the algorithms. And somebody was asking about overfitting. So 98% accuracy is not always overfitting, because uh, it may happen that the algorithm has widely understood the data. If the data patterns are having variety, lot of variety, then 98% accuracy is what is expected. But it is often difficult to choose performance measures. As you go through this course, you will see that different performance measures are used. So experience algorithms are termed as supervised learning algorithms or unsupervised learning algorithms based on the experience they are allowed to have on data sets. Okay. So machine learning systems can be descriptive. System uses the data to explain what happened, right? Example, like medical image segmentation, like what happened, what actually is there in the entire MRI image, where exactly is the tumor. In the MRI image, in a general image, if this image contains a cat or a dog, there is a dog. Like you can see that in CCTV footage, we generally use to find out what happened, whether there was anybody who actually came into my house or there was nobody. Face recognition, by looking at if you have a system of biometric system of entering, like allowing entries, then face recognition tells that yes, this is the person who has entered the who can be entered. And then visual surveillance is also one of the examples. Predictive, the system uses data to predict what is likely to happen: disease progression, autonomous driving. So the some car is approaching, likely to collide, so you change your lane. Prescriptive, the system will use the data to make suggestions about what action to take. For example, robotic surgery assistance or traffic management or many such things. Prescriptive. That can also be your, like in Amazon, Flipkart, they use, like, they give you some kind of some recommendation based on prescriptions. Then generation. So now, type of learning algorithm, there are three broad categories of learning algorithm. One is I can use ChatGPT to answer that. I'm sorry. So I just clicked my phone, and it said. So three broad categories of learning. One is supervised learning, unsupervised learning, and reinforcement learning. Well, there is another category that is important, that is self-supervised learning, but primarily we'll be talking about these three categories. So in supervised learning, like a teacher-student model, where data with labels are given. What are labels? Like when we say that 200 samples came for training the data. So out of these 200 samples, suppose there are 110 samples that were healthy category, and say 90 samples were unhealthy category. So these were labeled, the data of blood reports, the height, weight, and everything that were labeled by doctors that these are healthy patients, healthy humans, and these are unhealthy humans. So this is label, right? So data with label is given to machine learning algorithm for understanding, and it gives output that maps the input to the output. So a sample of, say, blood sample, height, weight, age, all this data is mapped to healthy or unhealthy, right? This mapping it is doing, and then there is a critique. That means it is the algorithm that we give to machine learning algorithm is to understand that where it has made error, and accordingly it improves its performance by repeatedly improving on the errors. Then there is unsupervised learning. In unsupervised learning, data is there, but there's no label. Like you see social media tweets that are there. Some tweets will look neutral, some tweets may be aggressive, some tweets may be negative also, but there is nobody who is marking them as good or bad. So these data samples come, and then machine learning algorithm learns to categorize those input data, tweets into, say, neutral, aggressive, negative, aggressive positive, aggressive negative. All these things can be done, and that is what social media platforms do. They find out by making use of these unsupervised learning algorithms, and sometimes they also take human assistance in labeling some of the data, not exactly the full data, because it is very difficult to label full data. So what happens here, that they find out the clusters of social media tweets that can be categorized into, say, good, then bad, or then neutral, right? So this is known as unsupervised learning. There is, as I told you, there is something called semi-supervised learning. This semi-supervised learning deals with very small number of labeled data and large number of unlabeled data. So this, somebody was asking, like, we are writing algorithms. Actually, we tell them how they should take experience from data. That is what we tell them. This is the training algorithm. Oh, sorry, I forgot to tell what is reinforcement learning. Because of the shortage of time, we may be skipping some of the things because I was telling you the answers. I will say that I will tell you what exactly is reinforcement learning a little later. So you can see that supervised and unsupervised learning. What is the difference? This label is not there. So training data can be text, documents, images, sounds. Their features are taken out. Like from the training data, what are the main features of training data? Right? Those features are taken out. And then they're passed on to machine learning algorithm. And machine learning algorithms, so we are actually assisting machine learning algorithm to learn better by taking out the features, right? So suppose it is a human face recognition system that I'm designing. So features will be humans' eyes, nose, ears, hair color, hair, and all these things, the skin color, skin, the shape, face shape. That is what is features, right? So those features are passed on to the machine learning algorithm. It learns to predict. And here, again, the features are passed on to the machine learning algorithm, but without label. Here you can see there is no label, right? So supervised learning deals with modeling conditional probability. Find out the probability of Y. What is the label Y? Given X, the image. Unsupervised learning is expected to model the probability distribution representing the given data X. I will tell you what exactly is meant by this. So observing sufficient number of examples of a random vector X. By random means what? From the city of Jabalpur, we are going house to house, but we are not going, we are randomly selecting some colonies in the city of Jabalpur, some posh colonies, some colonies where, say, lower middle income group lives, some colonies where families which are below a threshold of income they live. So, but then we will be randomly selecting some. So that is why this is random vector, where health data we are collecting from where, and associated labels. So after this, like we are showing the record to doctor and doctor is giving labels to them. So observing sufficient number of examples of a random vector X and an associated label Y, the algorithm learns to predict Y given X, right? This is known as a conditional probability. Estimating the conditional probability P of Y, happening of Y, given that X has occurred. Like given that a person's height is say 5 feet 3 inches, his weight is suppose 40 kilo, and age is suppose 23, then doctor says that he's underweight and so below health threshold. So what is the likelihood that X has occurred? That means given a sample X, what is the likelihood of this? Aditya is asking, training and prediction happening simultaneously. When it is being trained to predict, yes, that is happening simultaneously. But machine learning algorithms, after training, they are deployed on real world scenario, then they make final prediction. Just like when you become engineer, you are given a job to do a task. Before that, you learn, right? So here what we mean is that observing sufficient number of examples, that means it has learned. Estimating the conditional probability of Y given X. Given this particular type of sample, what is the likelihood that the person is having good health or the person is not having good health, right? This is known as, so given an image data set of satellite images, X, Y, where X is an image, Y is a label, from forest image, desert image, water body, or city. After observing enough examples of satellite images, the algorithm learns the features of each type of image. And on a new image X not seen earlier, it gives the probability. See, I seek your attention, please. Probability given this image X, what is the probability that it is a forest image? It is the image containing a desert. It is image containing a water body, or it is an image containing a city. This is called a classification problem. This is the task on which the machine learning algorithm is being trained. So you can see that this is the image. So image will also be converted into a digital format, like in terms of machine readable format, and a corresponding label will also be transformed to a machine label readable format, as you shall see in your lab experiments. ML algorithms are, so Shubham Kumar is asking ML algorithm and ML models. Algorithm is the entire process of training a model that, like, the entire algorithm is like, you become a doctor, the entire process of making you doctor, where you are a model and you are becoming doctor, right? How the entire process takes place, that is what is algorithm. And then you become a doctor. This is a in a crude sense. I hope I have answered your question. So, Shubham. All right. So now, similarly, this is desert. You can see that the corresponding label is given. And similarly, water body and city. So these types of images will be given, and then it will learn to predict. This is a classification problem. I give you another example. Given an image data set of images, XY, where X is the road scene image and Y is the center, height, and width of a bounding box containing a car or a scooter or a pedestrian. This is what is happening, being used in Tesla. Tesla uses its own algorithm, its own machine learning model to identify if there are objects in the scene, in the road scene. There may be an image that contains none of these also, right? So your road is clear, or it may be containing multiple cars, scooters, pedestrian, and whatnot, right? So, so KS Arya is asking, how exactly does the algorithm reduce the error in prediction? You will have to wait for some time. For that, you will have to first understand the mathematics behind it, and then to understand the algorithm is behind it. So please have some patience. We will definitely tell you how exactly it is done. Because in order to understand how a car functions, you will have to know the different components of a car, right? So it is just like that. Thank you. So for each object instance, a bounding box is present. There can be multiple bounding boxes in the boxes here, multiple bounding boxes in the vector y. So after observing enough examples of, no, sorry, not satellite images, of images, the algorithm learns to detect each type of object and estimates its location by predicting its bounding box. This is a regression problem. Predicting where exactly is the object is a regression problem. You are actually estimating the center, this is the center, height, and width of this bounding box. This is center, height, and width. So for each car, this is a different center, height, and width. So in unsupervised learning, so that was supervised learning. I gave you an example of regression problem and a classification problem. Now, unsupervised learning, observing sufficient number of samples X, the algorithm attempts to implicitly or explicitly learn the probability distribution of X. What does that mean? It means that what is that data distribution from where these samples are being obtained? It is learning that. So from, say, city of Jabalpur, if I'm taking the health record and family history of people, and then by looking at those health records, now there's no doctor who is labeling them that these are healthy, these are unhealthy. I'm looking at the whole population of Jabalpur. I've just taken 200 samples, and there are 15 lakh people in the city of Jabalpur. I would like to see if suppose these 200 samples that I've taken, although this is a very small number, let us take some 20,000 samples from the city of Jabalpur, and let us imagine that those samples are truly representing the data. What does that mean? That you have gone to every colony, and from there you have taken different samples of different age group, like 20 years, 5 years, 50 years, 70 years, 90 years. You have taken all age groups, you have covered, and so you have enough samples to train the algorithm, right? So what will happen that it will try to estimate that, okay, with bad health, there are like below health index, like below the threshold of health index, there is 57% population that is living below health index, right? And you have only 43% people who are above the health index. In fact, even less will be there, but let us assume. So I'm looking at the probability distribution of like different age people who are satisfying and who are not satisfying. So this is the probability distribution. I am looking at estimating this probability distribution of people with different age group which are above the health index. Okay. So there is somebody who is asking, Avishka Mittal, does the algorithm takes multiple images of some kind and checks the placement of each pixel in it and finds out the probability of that image of being objects? Say, I can't, my understanding, I just don't get it. So Avishka, we will let you know how this is done. They are actually given various images. Like I told you, 20,000 samples. They're given 20,000 samples. And then, so a lot of things are there. Then how does those samples are fed to this one by one? Then it learns. So multiple images are taken, not of the same scene, of different scenes. So it learns it learns to generalize the case. If X has two columns, then how the model makes probability distribution. We will tell you how to input data samples of different number of different type. It is not only, it can not only be a vector, it can be an array, it can be a tensor. By tensor, I mean that if there is an array and in this array, every single component can be of different dimension. That also is possible. Right. So medical images comes under which type of learning? So it depends, Rajesh Kumar, on which type of learning experience are you giving. If you are giving medical images without any label, then unsupervised learning. If you are giving medical images with label, then it is supervised learning, right? So unsupervised learning basically learns to understand the distribution of data, right? Patterns, it learns the patterns. Since there is no label attached with this, the algorithm must learn to make sense of the data without any guide. So from a cluster of cells in a given image sample, identify features that classify cancerous and genuine cells. For example, suppose these are points. So this is a population. This population is spread into three categories. Category, very good health, average health, and below average health, right? It can be very good, good, and below average, right? So this is how it happens. Now comes reinforcement learning. What is reinforcement learning? So some question again, for geospatial data for predicting any natural disaster, which algorithm and technique is to be used? Arpana Chaturvedi, for geospatial data, the same algorithm will be used that you will learn in this course. You can choose an appropriate algorithm for geospatial data, and you can, like natural disaster, if you have sufficient data, you can think of making your own model for disaster prediction. So reinforcement learning, as you can see that the agent is there. It is an artificial agent. It is observing the environment. It understands the state, the current state. and accordingly it takes some action, right? Once the agent takes an action, it is being rewarded or penalized. So we can see that learns from interaction with the environment to achieve a goal. Sorry, deals with agents that must sense the state of the environment. Number one, state of the environment, and take appropriate action to fulfill the objective. So suppose it is a humanoid robot and the task is to move from one place to another place, and there are several obstacles in it. So it has to make its own path based on the obstacles which are there and the place where it has to reach. At each state, it can see that it is reaching the goal or it may not be reaching the goal, right? So if it is taking a left turn, then it finds out that there are more obstacles, then it will have a penalty because it has to again further go right and then take action. So there is an state and it takes an action. Accordingly, rewards are there. It again is in different state and then again action, rewards are taken. These are accumulated, rewards are accumulated. So the current action influences the state of the world, which determines its reward, right? And then what will happen is that finally it will be able to achieve whatever task is given. So, for example, let us take this start position here. The model is given that you will get a +1 reward of +1. At the position 4-3, you have to reach position 4-3. Here is an obstacle maybe. And -1 at 4-2, right? And reward is -0.04 at each step, whether you go up, down, bottom. What is the strategy to achieve maximum reward? So action can be up, down, left, right, right? So transition, so this I'm giving you just one very simple example. But normally what happens is transitions and rewards are not usually available beforehand. How to change your policy based on experience? Your policy is that I will be going up, 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 and then this, how to change our policy that I maximize the award, or how, should I change this, take it to be like this, right? So how to explore the environment? These are the problems that reinforcement learning deals with. Well, some popular learning algorithms are, say, K-means is one of them, principal component analysis, Gaussian mixture model, and then support vector machine, neural network classifiers, decision trees. There are several such models. And these are unsupervised models that I mentioned here, first three models, unsupervised learning algorithms. They use unsupervised learning algorithms, and these are supervised learning based, algorithm based models. So so Sangeeta Trehan, when we do more on reinforcement learning, we will be explaining. Definitely, please have a little patience. We will have dedicated sessions on reinforcement learning also. So for now, just let us think that a child learns to ride a bicycle. So every time it is able to maintain the balance and move forward, there is a reward. And every time it falls, the child falls down, it is a penalty. So ultimate goal is to learn, right? Because we will be coming one after the we will be covering each topic one after the other. So I will be covering here just briefly two topics. One is K-means clustering, just to tell you how unsupervised learning happens, and then how supervised learning happens. So K-means is a partitional clustering algorithm. It partitions the given data objects into K clusters, and therefore we call it K. So actually it is user specified numbers. Like if I want to specify health index into very good, good, and poor health index, then K is 3. Each cluster has a cluster center, right? Called centroid or prototype. And number K is selected either through a guess or using some prior information. So just look at this. Here we have, suppose you have three categories of data: very good health, and poor data. So what we do that initially we select an arbitrary center. Here we have selected, randomly select center. We randomly select centers, right? This is what we are doing. Then what we do is that we find out each point, each single point. Suppose this point, right? Each single point's distance. Suppose this point, distance from here, distance of this point from here, distance of this point from here, distance of this point from here. So for each center, I will find out the distance of all points in that set from that center, right? First with this center, second with this center, third with this center, right? And what happens that, Rohan, number of K will not depend on the number of features. It will depend on your data is coming in how many categories. Suppose data is coming in 3 categories. Data is, you want to sort out in 3 categories. Then in that case, K will be 3. Abdul Mukhi, we will be dealing with reinforcement learning in a later session. Please have a little patience. We will be covering all the topics which are important for current deep learning and applications. So please let us now focus on K-means. So we can see that after it has each point, we will find out the distance. And suppose this is the point, right? Suppose this is the point. This point's distance from here, this point's distance from here, and this point's distance from the third one. Whichever is the lowest distance, I will say that this point is assigned a cluster whose center is this, right? So accordingly, you can see that I have colored it. So each point is assigned a cluster. So this point, this is a cluster. Then you have this cluster colored by green. You have a third cluster, right? Right. So suppose these clusters are created. Then what I will do, I will again find out the mean of this, and mean of this. So the mean is found out. Mean comes out to be somewhere here, and somewhere here. What I'll do is that I will be again finding out the distance of each point, like this point from here, this point from here, this point from here. And whichever point is having the closest center, I will assign that cluster to this, right? So suppose this point is closer to this center, and this point is closer to this center, then I will be assigning these centers. Accordingly, you can see now the centers are differently assigned, right? So you can see that K-means is an iterative algorithm which will first find out randomly selected centers, find out the distance of each point from the 3 selected centers. Whichever is the closest center, I will assign that cluster to this point. And then I will take the mean of that cluster and define that as the center, new center. I will keep on doing this, right? So Given a data set, randomly select k data points as initial centers. These are centers. Seek your attention, please. Set r minus 1, r is equal to 1, sorry, set r is equal to 1. Set r is equal to 1. Then let us repeat these steps as I told you. That for each center, find out the distance between each data object and the center. Assign each object the cluster having least distance from its center. Distance measure can be chosen as per the data characteristics. For example, it can be the Euclidean distance, like distance between objects, which we can visualize as the main distance, right? Or it can be any other kind of distance, Hamming distance, if it is a binary data. Rth step, at the rth step, each cluster is made as follows. So, how do we define close to the centroid? Good question, Jayesh Chodia. Close means we will make use of some distance function. So here distance can be Euclidean distance, right? Euclidean distance means if there are 2 points, I hope you know what is meant by Euclidean distance, the distance that we are familiar with. If suppose there are 2 points, x1, x2, y1, y2, then x1 minus y1 square plus x2 minus y2 square, and then take the square root of this. This is my Euclidean distance. That is one distance. Or if it is Hamming distance also, like number of difference in zeros and ones, if it is a binary data, right? So at rth step, each cluster is made as follows. That each cluster is like, the center is XP is the center. XP is belonging to a center where its distance from this center is smaller than its distance from any other center, right? This is how clusters are created. So then we repeat r is equal to r plus 1. That is, we update the centers. How? By taking means. I take the new I create a new center by taking the average of all points in that set. So this is what is this? This is the size. If suppose in a center in CRI, there are say 150 points, then this CRI mod is nothing but 150. And I take the average of 150 points. So Rohan Bose is asking why not Manhattan distance? Why? You can choose any distance function based on the data type. What is your problem? What is the data type, right? So any distance you can choose. So they have taken a Euclidean distance. So after the algorithm halts, we finally get K clusters. Halts means when there is no difference. Next time when you find out the mean of the cluster, it turns out to be the same mean. Then you will be having no further, you cannot have any further new clusters. So K-means strives to minimize the sum of the squared error to scatter. Like what is the each point belonging to its cluster, and all K clusters, this should be minimized. That is the idea. So K-means algorithm is like somebody was asking, how do we tell the error? So this is the error, sum of the squared errors, right? So if this is, it keeps on iterating itself so that this error is minimized, right? K-means algorithm. So note that it does not guarantee to reach the global minimum, but it is minimizing the error. So easy to understand and implement. It is very efficient. The time complexity is T, where N is the number, TKN, where N is the number of data points, K is the number of clusters, and T is the number of iterations. Because N is normally very high, large number of points. and K and T are small, so K-means is considered as a linear algorithm in N, big O N. K-means is one of the most popular clustering algorithms. It terminates at a local optimum if sum of square error is used. The global optimum is hard to find due to complexity. So, because people have found out that if I use the Euclidean distance or any other specific distance, so we, based on the distance function, you see that the data should be spherical, right? What I mean by this, I mean, what do I mean? Let me tell you. Global minimum, local minimum. So somebody is asking global minimum, local minimum. You will come to these mathematical concepts clearly. SSE is a number. It is the sum of the squares, right? It is a number. It is a function of what? The centers and the distance of each point from centers, right? Distance of each point from centers. These are centers, I centers, and then, sorry, this is P, and then these are centers, mu I. So this is a number which is a function of xp mu I, and this function will achieve its minimum at some points. If I change mu I, this will be changed. So it will have a local minimum and it may have a global minimum as well, right? So by local minimum, I mean the minimum of absolute minimum of this error function. I was telling something. Yeah, so weaknesses of this. Is it possible that some points might overlap in two different clusters? If they are having the same distance from two different clusters, then they are assigned one of those clusters, right? Because here it is absolutely based on distance. So they are assigned one of the two clusters. One number is, suppose we do not have any idea of what is K. So this is one of the weakness. Algorithm is only applicable if the mean is defined. For categorical data, centroid is represented by most frequent values also. It is sensitive to outliers because if there are some outliers, then it will take the mean and its mean will be drifted away from the actual population. Poor random initialization also may lead to bad cluster quality. And K-means algorithm is not suitable for discovering clusters that are not hypersphere. But I mean this, like for any point, those which are within this radius, they are close to this point. If I choose this center, then whichever points are closer to this will be specifically in a sphere, right? Hypersphere means in high dimensional sphere. So that is what is in high dimension sphere is known as a hypersphere. And it depends on the type of distance function that I choose. So remember that how clustering should be measured, like performance measure I was talking about. Clustering algorithms have, like they have performance based on two things. One is compactness, that in each cluster, the point should be as close as possible. Like we should not be choosing points which are far away from this center of the cluster or from the main population. And sum of the square error is commonly used for measuring compactness, but inter-cluster separation, like two clusters should have good separation of points. So compactness and isolation are two measures which are used. In most applications, expert evaluation still prevails in this. Well, several variants have been proposed over a period of time. K-means plus plus, fuzzy C-means, K-metoids, and then deterministic K-means algorithm we developed here in our with one of our PhD students. Now I come to supervised learning. Quickly, I will tell you, because artificial neural network we will be covering in detail in a later session. So it is an information processing paradigm which is inspired by human brain information processing mechanism, because I want to tell you what exactly is meant by deep learning. So they learn by experience, just like human learn. So this is a model of neuron, which is the main purpose is to receive signal, like while I'm talking to you, I'm also listening some noise which is outside noise. I can see my surroundings, so that is something that I'm receiving every single second, fraction of a second. And same thing is for you as well. You are listening to my lecture while you're also having a sense of the surrounding. Analyze and transmit further the information in a form of signal. So they receive signal, they analyze and transmit. So you can see that these axons help. These are, through this they receive. This is the processing element of neuron. This nucleus. When a neuron sends information, we say that it fires. Acting through specialized projections known as dendrites and axons, neurons carry information throughout the neural network. We have thousands and tens of thousands of neurons in our brain, and they carry information. Now, how do they do that? Let us take a simple model of 3 neurons, okay? Just 3 neurons. And suppose your data set is a vector containing 1.4, 2.7, 1.3 entries, right? Suppose there are 3 entries, okay, one, and a category, a label is defined. It is of class 0, right? And another data point, you can see this label is defined for this data point, and so on. So there are so many data points, data set is there, and labels are defined, right? Now, what it does, each data here is, say 1.4 is 1, 2.7 is 1, 1.9. It has 3 features. Data has 3 features. We call it feature. Each data point is separately passed on to a neuron, right? It is receiving this data, analyzing the data, and then passing further the information. So here in this neural network, there is an input layer, this is a processing layer, and this is an output layer. What it is doing, it is taking decision, right? Deciding whether this is of class 0, making prediction whether the class 0, class 1, whatever. So you can see what is worth observing here, that each neuron is independently doing its job and passing further the information, right? They're doing independently. But all 3 neurons will be independently processing the input. And some neurons may not consider, say, this feature to be important. One neuron may not consider this feature to be important. So they're independently processing. So let us see what is happening. We train the neural network by initializing the weights that it assigns to these 3 inputs. Each neuron will be assigning a different weight, right? This is randomly initialized, because when a child comes to this world, he is having a random understanding, like everything it learns by looking at the patterns. Then we present a training pattern and feed it to the neural network, get an output and compare with the actual value. So the output we are getting is 0.8, whereas the class is 0. So error is 0.8. We then adjust and update the weights. And this is the crux of neural network training. How do we adjust and update the weights is the crux of training network. This is what we will be covering in future classes. So it is adjusting by back propagating the error function, right? And we repeat this process to reduce the error. We keep on giving one after the other, all these experience to the neural network. But my dear friends, there are a lot of things that people observed over the period of time, that they need this traditional machine learning algorithm need human intervention to extract useful features. So if a data of 20,000 samples, for these 20,000 samples, you have to extract features of, say, face. Suppose these are face samples, examples of face images. You'll have to extract where is the eye. These are known as fuchsia points. You have to actually look at some of the position of eye, position of nose, position of lips, and all those things. So these are application features are application dependent. If it is face detection, the features will be different. If it is a car detection, feature is different. Malignancy dependent on MRI images, features will be different. So they are manually designed features, and this could be incomplete. Sometimes they can be over specified. So developing handcrafted features is a time consuming and complex process. So what happens that deep learning came as a new paradigm of training deep neural networks. So earlier we used to have input, say it is a car image, right? Input. Features were extracted using a separate algorithm by human intervention. And then this was sent to a classification. For example, if it is a classification problem, whether the image contains the car or no car, then it was able to do that. So this feature extraction itself was very costly affair. Then now came deep learning, where feature extraction was done by the initial layers of neural network itself. And then the classification task was also performed by neural networks, right? So what happens, what is the basic difference between traditional machine learning algorithms and deep learning algorithms, which is a maybe branch of this, that they were able to learn very well the features themselves. So deep learning models learn rich hierarchical representations automatically by extracting features at different level, like at initial neural network level, very low level features will be extracted. Then at second level, that the third level, that 10th level. So they provide a flexible learnable framework. So what happens that, suppose this is an image where a bird is seen hidden in a flower in flowers. So here what we have to identify is a bird, right? What happens that low level features will be identifying, like for example, colors or edges. Mid-level features will be combining these low-level features to create some such structures. And then we will be having high-level features, which will look more abstract to humans, but they are more machine understandable. Like neural networks understand them better. Then, so these features are obtained at different levels of neural network, right? And then they are passed on to a trainable system, which gives the output, right? So what I mean to say is that at this, they learn the hierarchy of features by combining low-level features to obtain new features, and then again at the second level. So this is known as feature representation learning, that they learn from this. I hope this is clear to you that there's a basic difference between traditional machine learning algorithms like SVM or others. So why this deep learning is so successful in this last decade? Because now we have increased availability of data. You have huge data that is available. So that is giving number of instances of same type and different type. Variety in same type, variety in different type, right? So like human population is having a lot of variety. In India itself, we have people north and south, their faces are different type. East and west, their faces are different type. Natural scenes from north to south is different, from east to west is different. So we have increased availability of data, significant improvement in computing power. And then what is very important for you to understand, these are not the only things, new ways of learning a representation. That Jeffrey Hinton, John Hoffield, like people gave a way, they paved the way for deep learning models to learn differently. And then use of very deep learning, very deep learning architecture. Like I told you, ResNet was a 152 layer model, huge model. So what are these? Like what happens? Then you have more number of neurons, you have more memory and processing power, right? Each neuron is having a memory and processing power. So since you have more neurons, more processing power, so they are able to generalize well and are flexible. What is meant? So there are a lot of different types of neural networks like multi-layer perceptron, con layers, con neural networks, then recurrent. Con were useful for image and video. They are useful more for sequential. Generative adversarial network for generative model. Then we have many other models that are there. So as a result, you see that deep learning is embedded with your everyday life, whether it is internet and cloud, medicine and biology, media entertainment, security, autonomous machines. Think of anything, you'll find deep AI is there. So the changing landscape with generative AI, which is why we thought that, like Dr. Rakesh Sanodia thought, and with his colleagues, they thought that why should we have this summer school, just so that when you participate in workshop, you are enriched with knowledge and you can meaningfully can contribute as well. We can see that Gen AI capabilities now, that there are foundation models which can do multitasking, like they can summarize, they can expand, elaborate. There are chatbots. They can give you inference. They can give you some kind of transformation. So rather, like you can see the text, video, audio, code, image, all these things are possible. But we have to also look at the critical consideration, um, like data availability and quality. So neural network is only a specific component of the entire Gen AI family. There are several types of neural networks. Somebody is asking, is spiking neural network. So what we can do is that you can explore. It is always possible to explore with different neural network structures, what is possible and what is not possible. So I would not say anything impossible at this stage. As you go through this course, you will come to know that many things are possible and many limitations exist. So our friend Dr. Gopi Chand very well said, data availability and quality, transparency, ethical issues and bias, privacy issues, data misuse and mass surveillance, misinformation, deepfake, lack of regulatory laws. I will quickly go through this because of that shortage of time. Data availability and quality. My dear friends, even if you are not an expert in AI, you can definitely contribute by by labeling data, by creating data sets, and by labeling them, assisting AI models to learn better, right? And although we have lot of data availability, but people from least developed countries, developing countries, and like in Asian and African countries, we need to also work on equalizing the data so that bias is not there. Most of the machine learning algorithms and deep learning algorithms are trained on data from Western world or developed countries world, but not from the least developed countries or lower income group companies. So that because of the bias, your machine learning algorithm will not be able to learn well. There is no minimum samples data, depends on the type of task, how difficult is your task, data quality and variety requires to be accordingly checked. Privacy issues, because what happens that you are having CCTV, you are having your inputs on Facebook and LinkedIn and whatnot. How your data is being misused, we have no idea. And then we saw that deepfake came out as a very shocking, unethical application of deep learning, where some celebrities' data was misused. Well, there is no regulatory law that is there in most of the countries. Like if suppose Tesla cars collides and hits somebody, who will be responsible? There was a news that in 2018 a case was registered because a woman died due to car accident in US. And in 2023, I think the verdict came because there was no regulatory law. So verdict came from Supreme Court, where so it took some 5 years to understand. And so European Union has come out with uh, a regulatory law, and other countries, even our own India, is also working on that. So if suppose some AI decision is wrong, how who will be held responsible? How do we make ethical use? How do we ensure that the data from whom we are taking data are properly rewarded, properly compensated? Well, with these words, I would like to say that you have a lot more uh, sessions to learn. And these are some old text references that I used while I was learning deep learning. And Ian Goodfellow is a very good deep learning book which is available. NGNG, everybody, I think those who want to learn know that their lecture slides, their lectures are wonderful. With this questions you have already asked, and I would only say that C.V. Raman, one of our top-notch scientists from India, he really wrote his quote, I think is very important. Ask the right questions and nature will unfold it. This open the doors to her secrets. That is what is happening, right? So, Jayesh Chodia, you will come to know what is a perceptron soon, because perceptron is perceiving information, processing information, and passing it on to the next layer, right? So we will come to know about it. This was only a very brief introduction to what is AI, what is machine learning, and what is deep learning, right?
Thank you, ma'am, for your um, learning, and we are pleased that you contributed so much for the session. And we shall take a break then.
Thank you. Some question, in fact, the way humans have innate intelligence to, just a minute. Somebody is asking, Pooja is asking, Pooja Soni. Can we call machines truly intelligent or just trained? I did not discuss here the current level of intelligence. We will say that currently it is a machine learning. They only learn a couple of tasks, but machine intelligence is what we are achieving, trying to achieve. So we cannot say that we have achieved a level where we can say that the machines are as intelligent as humans. So they are learning on different tasks, like we say that detect cancer, detect where there is a car or not, find out what is the weather tomorrow. So it's if a algorithm learns to understand the patterns of data for weather forecast, it may not be doing the same other things with the same efficiency. So machine intelligence is yet to be, it's called artificial general intelligence that is yet to be achieved. And then there is a third category. So currently we are in the phase of narrow artificial intelligence. From here, we are moving towards artificial general intelligence. Priyank More, agentic AI is used in a medical domain. What are the specifications? It depends on the application. Different application may demand agentic AI. If agentic AI is assisting in surgery, its specification will be different. If agentic AI is helping, assisting in just clustering the data into two categories, its specification will be different. Will we learn about different data types like text, tabular data, and images and video and audio files, and how make them go through the model pipeline? While you will be given experience of training experience on different types of data. These things will be covered. Most likely all the things will be covered. What are the components of a neuron? What does it store and process? So neural network is having memory, which is stored in terms of weights that I told you, in randomly selected weight, and it has own biases. What does it process? Processes the input with respect to the weightage it associates to different features, right? Different features of the data, it associates a different weightage. Like I'm giving attention to your question, so I'm giving higher weightage to your questions right now. Rest of the things, like something is moving here, there is a tree in front of me, I'm giving low weightage to that. How to achieve this? Yes, we are Priyanka More. How to achieve this? What no, so to achieve this, you have to define the task. As I told you, this is narrow AI currently. You'll have to define the task, right? Then you will also know how do you achieve that, okay? What is the difference between agentic AI, generative? We will be discussing all these things. Agents, generative AI can be an agent as well. And then we have in deep learning model, learning, the model is at fully connected layer only. No, Shubham, that's not there. So with that, I would like to stop sharing, and thank you all for your wonderful interaction. I really enjoyed taking this session. I hope that all of you will keep asking questions so that whosoever is the speaker is also will be like will be happy to interact with you. I will be giving my slides, and these lectures are also available on YouTube, so you can definitely learn from YouTube. Thank you so very much.
Thank you, Professor Ojha, for your wonderful speech as usual. Yeah, so I hope that all the fundamentals knowledge, like before going dive into the deep learning, so you have already given the overview of like how it is evaluated, means how it came into the picture. Like most of the time we forget about talking about AI applications, and machine learning. So what are the techniques are there? So here in your lecture, what I found that you have covered each and every things, like which basically we are going to use. So all the overviews are introduced by you. So once again, thank you, Professor Ojha, for your wonderful session.
Thank you so much. Thank you, everybody. Thanks, Dr. Rakesh, for giving me this opportunity. Thank you, Gaurav, and thanks all the participants as well. Thank you.
So participants, the next session is going to start from 2:30. And meanwhile, anyway, like, so they will share with you the YouTube link, and all the recorded session will also be given to you. So if you, those who have missed, so they can watch through this YouTube link. And they will also upload all the PPTs in the Canvas, our framework. So please, I request you that please join that canvas, those who have not yet joined. So thank you very, very much. So we will meet you at 2:30 then. Thank you.